Now, in triangle ABC, we have to start by figuring out what we're given and which law we should use, whether it's cosine law or sine law. And we're given two side lengths and the contained angle. And that means that we can find the side opposite angle A, which we're going to call little a, or side length BC. We can use cosine law in order to find that measure. So what we're going to do is write our cosine law for finding side length A, which is a squared plus b squared plus c squared. Sorry, a squared is equal to b squared plus c squared minus 2bc cosine A. We're going to sub in, and here b is 12, c is 8, and angle A is 65 degrees. And so when we simplify, we find A is going to be equal to the square root of 210 minus 192 times cosine 65. All right, so we put in the bracket first to do this all in one step, and 12 squared plus 8 squared minus 2 times 12 times 8 times 65 cosine, and we'll close the bracket. And then we have to take the square root of this. So if we're going to round to one decimal place here, it's 11.3, and the units would be meters. So A is approximately equal to 11.3 meters, and we can put that on our diagram. So now we have an angle measure and the corresponding side length, and we can find either angle B or angle C using sine law. And we're going to use sine law to find angle C now, and we'll sub in what we know. C is 8 meters, angle A is 65 degrees, and side A is 11.3 meters. So now we're going to multiply both sides by 8 to isolate sine of C on the left-hand side. And now we're going to take the inverse cosine of the inverse sine of everything in the bracket. So we'll put in brackets, and it's 8 times sine of 65 divided by 11.3. Close the bracket, and we'll take the inverse sine, and we get approximately 40 degrees. So angle C is approximately equal to 40 degrees. So we can label that on the diagram. Now we know two angles in our triangle, and we can find the third angle. So angle B is equal to 180 minus 65 minus 40. So angle B is 75 degrees. So now solve triangle RST.